Welcome to The Explainer. Today we're diving into a really fascinating and honestly pretty counterintuitive argument about the AI boom. It challenges the one thing that almost everyone just takes for granted, that we need to build a mind-boggling number of new data centers.
Right, we all know AI is just incredibly hungry for computing power. I mean, from training these huge language models to just running our favorite apps, the demand for powerful GPUs is absolutely exploding. So, the race is on to build these enormous, power-hungry data centers just to feed that appetite.
But what if that's not the whole story? This explainer, and it's based on a talk by Dr. Jasper Zhang, who's the CEO of Hyperbolic, proposes a totally new way of looking at this. He argues that we're all focused on solving the wrong problem. Okay, let's get into it.
So first, before we can really understand the proposed solution, we have to get our heads around the sheer, almost ridiculous scale of the challenge that everyone is trying to solve right now. A McKinsey report estimates that just to keep up with AI demand by 2030, we would need to build 4 times more data center capacity than exists in the entire world today. Just think about that for a second. Everything we've built so far, times 4, in just a handful of years.
And here's the kicker. Even if we could build that fast, we can't get power to them. In a key hub for data centers like Northern Virginia, the wait list just to get a new facility connected to the power grid is 7 years long. So a facility planned today, it wouldn't even be online until the next decade. And the cost? It's just staggering. A single, top-of-the-line AI facility, something like Microsoft's Stargate project, is projected to cost over $1 billion, and we'd need hundreds of them.
So the numbers just don't add up. Even if we throw trillions of dollars at this and build as fast as humanly possible, we're still projected to fall way short. The strategy of just building more and more and more, well, it seems like a dead end. So what critical piece of the puzzle is everybody missing?
And this is where we get to the core of Dr. Zhang's argument. This is the big twist in the story that completely reframes the whole problem. It's not just about a lack of supply. See, it turns out we are unbelievably wasteful with the resources we already have. Research shows that those powerful, super expensive GPUs inside our existing data centers, they're sitting idle, doing absolutely nothing, a whopping 80% of the time. So the crucial point is this. The crisis isn't just a physical shortage of chips. No, it's a problem of allocation and access. We have a massive amount of computing power that's already built, already paid for, already connected to the grid, and it's ready to go. But it's fragmented across all these different providers, sitting locked away, totally unused. So if the real problem is fragmentation and inefficiency, then the solution isn't just about building more hardware, it's about smarter software. We need a system that can find all of these idle resources and get them to the people who need them efficiently. And the proposed solution is something called a GPU marketplace. You can think of it like a global operating system for all the world's computers. It doesn't own any of the data centers itself. Instead, it creates the software layer that connects them all into one giant, accessible pool of power. And the way it works is actually pretty elegant and simple. First, providers with those idle GPUs just connect to the network. Then, the marketplace aggregates all that power into one unified pool. And finally, developers can rent exactly the compute they need for exactly as long as they need it. This simple act of aggregation, it changes everything.
So what happens when you unlock all this wasted supply and you create a real competitive market? Well, basic economics takes over. The price plummets. Renting a top-tier H100 GPU from one of the big cloud providers might cost you around $11 an hour. But on a marketplace that taps into all this idle supply, that same power can drop to less than $1.
Okay, so what does a price drop that dramatic actually mean for, let's say, a startup that's trying to build the next big thing in AI? Well, the impact isn't just big, it's transformative. So let's take a look at a typical startup. Say they need about 1,000 GPUs. In the traditional cloud model, these rigid, long-term contracts can drive the cost up to nearly $44 million. And why? Well, it's because they're forced to pay for all that capacity, even when they're not using it. But with a marketplace, they can rent flexibly, scaling up only when they really need to. That total cost? It drops to under $7 million.
That is a 6-fold difference. But here's the really crucial shift in thinking.
This isn't just about saving money. What it really means is that for the exact same budget, a startup can now get 6 times more computing power. And this is the most critical takeaway of the whole thing. Just like Dr. Zhang says, it's not about saving your cost by 6x. It's about increasing your productivity by 6x. And in AI, more compute means better models. It means faster experiments, more innovation. All of a sudden, building a world-class AI model is no longer something that only a few giant corporations can afford to do.
So to kind of wrap up the key points here, the AI compute crisis, it's as much a problem of inefficient allocation as it is a problem of supply. A software-based marketplace can unlock this vast wasted power from idle GPUs. And that, in turn, leads to not just way lower costs, but a massive boost in productivity. It democratizes access and could potentially accelerate the entire field of AI development.
So that leaves us with this final, really provocative question. If the biggest barrier to building the future, the sheer cost of AI compute, suddenly becomes 6 times smaller, what new ideas, what new companies, and what kind of future are we all going to build?